In this session we will discuss exam style questions on the topic electric circuits. So 3 voltmeters are connected as in figure 4.325. So this figure, this voltmeter, and this is voltmeter. What is the voltmeter reading XYZ in the table below, which are obtained with the 3 different batteries. So this V1 is basically given X 12 and this is 6 volts. So this X is basically is V. So this voltage is 12 volt and this voltage is 6 volts. So this voltage should be 18 volts. So this is 18. So if this is this voltage is 6 volt and this is 4 volt, so the difference between these two is here. So this is basically 2 volt. Y is 2 volt. So Y is 2 volt. Similarly for the third one, 12 plus 4. So this is 12 and this is 4 volt. So this is 8 volt, because the difference between these 2 volt, 2 difference will appear here. So this is 8 volt. So the Z in place of Z, it would be 8 volt. So this is very important. The resistors R1, R2, R3 and R4 in figure 4.36 are in equal values. What would you expect each of the voltmeter A, B and C to read, assuming that the connected wires in the circuit have negligible resistance? So this is 12 volt, this is R1, R2, R3 and R4, and all have same resistance. So figure 4.3.26, R1, R2, R3, R4 each have the same resistance, is R. So this R2 is basically so the equivalent resistance is 4R. So the total resistance or equivalent resistance is 4R, 1R, 2R, 3R and 4R. So the total equivalent resistance is 4R, and 4R divided by 12 volt. So 12 volt will be divided by this 4R. So this is 4R and this is upon 4R, V upon 4R. So current, whatever the resistance, so in place of resistance we are using R. This is R, 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 R. So R1, R, R plus R plus R plus R. So 4R 12 volt divided by 4R gives the current flowing through this circuit, and the potential difference across this resistance will be V upon 4R multiplied by R1. So voltage drop across this R1 is equal to V1 is equal to this current into R1. This is current. So this is R1 is basically R. So this R cancel. So V upon R. So this is 12 volt. So divided by 4 volt. So this is 3 volt. So 3 volt appear across this resistance. Similarly for this 3 volt will appear and 6 volt appear, because 3 volt, 3 volt. So this will read 6 volt. So this is simple. Now calculate the effective resistance between A and B in figure 4.327. So this is 4 ohms, this is 4 ohms. So the effective resistance will be half of this. So 4 ohms into 4 ohms divided by 4 plus 4. So this is 16 ohms, 8 ohms. So the effective resistance will be 2 ohms. Figure 4.328 shows 3 resistors. This is 6 ohms, 2 ohms and 6 ohms. So this is a parallel combination, because these 2 points are common for these 2 ends, and similarly for this. So we will calculate the effective resistance across this parallel path first and then add this series. So this is 6 into 2 divided by 6 plus 2 plus 6 ohms. So this is 12 plus 8. So this is 1.5 plus 6 is equal to 7.5. So the effective resistance is 7.5 ohms. from here to here. The resistance of value 6 ohms, 7 ohms and 8 ohms are connected in series. Calculate the combined resistance of the resistor. So 6 plus 7 plus 8 is equal to 21 ohms. The resistance of one of the resistors increases. The resistance of one of the resistors increases if the current flowing through the combination must remain unchanged. Does the supply voltage need to be increased or decreased? So the since so if resistance increase, the current will decrease. So in order to maintain the resistance, the voltage has to increase supply accordingly. If the resistance increases, the supply voltage should also increase for unchanged current. Give two advantages of connecting lamp in parallel. The potential difference across each lamp is fixed at the supply potential difference, so the lamp shines with the same brightness irrespective of how many other lamps are switched on. So this is very important. The advantage is this, that each lamp will glow with the same capacity. Each lamp can be turned on and off independently. So in case of series lamp combination, if one lamp is off, the other lamp will automatically off. So in this way, if parallel combination, so if each lamp can be turned on and off independently, if one lamp fails, the other can still be operated or on. The two resistors of the same size are connected in parallel if the resistance of the combination greater or less than one of the resistors are connected in parallel. If they are connected in parallel, if the resistance of the combination greater or less than that of one of the resistors, the effective resistance will be even lesser than the less one of the resistor. So the resistance will be lower than the lowest resistance exists in parallel combination. It will be lesser than the less resistance. So this is very important. What are the readings? V1, V2 on the high resistance voltmeter in the voltage divider circuit of figure 4.329 if R1 is R2 is equal to 10 kilo ohms. So if these are two equals, then the voltage drop across this will be same, half and half. So this is 3 volt, 3 volt. So if this is 10 kilo ohms, so this is 6 volt is applying. So in place of this 6 volt, this is 10 kilo ohms, and here we have 10, 10. So this is 10, 10 is 20 kilo ohms. Divide, so we have half, so 3 volt. So this is 3 volt, and similarly for this is also 3 volt. This is the first part. In the second, we have this is V is 6 volt, so this is 10 ohms, 10 plus 50, because this is 50 kilo ohms, so 50 kilo ohms. So this is 1 volt. So 10 kilo ohms is 1 volt, and 50 kilo ohms is 5 volt. So this is again 6 volt total. Similarly for the last one, 20 kilo ohms and 10 kilo ohms. So this is 6 volt, this is 20 kilo ohms, this is 20 plus 10 kilo ohms, so this is 30. 20 divided by 30 into 6 is 4 volt, and for this 10 kilo ohms 20 plus 2, so 10 upon 30 into 6 is 2 volt. So this is total is 6 volt. Here total is 6 volt supplying source, total is again 6 volt. So the resistance will appear like this. So this is very important. This question is very important. Now from 6 to the last we will discuss in the